The reality is this system hasn't changed, not in the way that matters most. The same volcano that triggered a silent tsunami in 2018 is rebuilding itself layer by layer on the exact same unstable foundation. Each eruption adds more weight, more pressure, and more risk to a structure that has already proven it can fail without warning. Scientists are watching it closely, tracking every tremor, every gas release, every shift beneath the surface. But monitoring is not the same as prevention. And data alone doesn't save lives when it doesn't reach people in time. What makes this situation different is speed. When collapse happens, waves don't wait. They move fast, often reaching coastlines in under 30 minutes faster than most warning systems can react, and far faster than people can fully understand what's happening. So the real question isn't whether it could happen again, it's whether anyone will be ready when it does. Subscribe to the channel to stay ahead of critical events like this. Like, comment your thoughts, and share this with someone who needs to see it. Anak Krakatau sits in the middle of the Sunda Strait, a narrow stretch of water between Java and Sumatra, one of the most densely populated regions on Earth. At first glance, it doesn't look like a global threat. It's just a small volcanic island, rising a few hundred meters above the sea, surrounded by fishing boats and tourist routes. But what lies beneath it tells a very different story. This island is not stable land. It is the growing tip of a much larger volcanic system built inside a deep underwater caldera left behind by one of the most violent eruptions in recorded history. Every year, new material is added to its cone, layers of ash, rock and magma, slowly stacking upward, forming steep slopes made of loose, fragile deposits. As of March 2026, Indonesia's volcanology agency raised the alert level to 3. Dense grey ash is rising up to 2.5 kilometers into the sky. At night, glowing newt fragments can be seen ejecting from the vent. The exclusion zone now extends 5 kilometers in every direction. But the real danger isn't just the eruption you can see. It's the structure you can't, because this entire cone is sitting on the edge of an underwater cliff, unstable, constantly growing, and already proven to fail. On the night of December 22, 2018, nothing seemed out of place. There was no earthquake, no shaking ground, no sirens. Along the coastlines of Java and Sumatra, people were doing what they always did, attending concerts, relaxing at beach resorts, spending quiet hours with their families. The sea looked calm, the sky gave no warning. Then came a sound, not an explosion, not a tremor, just a deep growing roar from the direction of the ocean. By the time people turned to look, it was already too late. What happened beneath the surface was both simple and devastating. The southwest flank of Anak Krakatau, a massive section of the volcanic cone, suddenly collapsed. In a matter of minutes, an enormous volume of rock and debris slid into the sea, displacing water with incredible force. There was no seismic signal strong enough to trigger warning systems. No fault rupture, no detectable pattern. The system stayed silent. 24 minutes later, the first wave struck the coast of Banten. 33 minutes after that, they reached Lampung. Entire coastal communities were caught completely off guard. Hotels, homes, and crowded beaches were hit without a single second of warning. More than 400 people lost their lives. This wasn't a failure of technology. It was something far more dangerous. The system had been built to detect the wrong kind of disaster. To understand what really happened in 2018, you have to look beyond earthquakes and focus on something far less visible but equally powerful structural failure. Volcanologists call it a flank collapse. Unlike a tectonic event where plates suddenly rupture and release energy as seismic waves, a flank collapse is mechanical. Over time, a volcano builds itself upward using layers of ash, fragmented rock, and cooling magma. But these materials are not solid in the way most people imagine. They are loose, unstable, and often poorly bonded, especially along steep slopes. At Anak Krakatau, this process had been happening for decades. Each eruption added more material to the cone, increasing its height, its weight, and the pressure acting on its flanks. Beneath the surface, gravity was constantly pulling outward and downward. The southwest side in particular had become oversteepened and structurally weak. Then, during an ongoing eruptive phase, the balance failed. A massive section of the cone broke loose and slid into the ocean. Not explosively, but rapidly enough to displace an Ogromny volume of water in minutes. That displacement is what generated the tsunami. And here's the critical difference. This kind of collapse does not always produce a strong seismic signal. There is no clear fault rupture, no distinct waveform that traditional warning systems are designed to detect. So from the perspective of the system, nothing happened. But in reality, everything had already begun. What makes the 2018 disaster even more unsettling is that it wasn't entirely unexpected. Years before the collapse, scientists had already outlined the risk in detail. In academic papers published as early as 2012, volcanologists identified the exact conditions present at Anak Krakatau, a rapidly growing cone, steep, unstable flanks, and layers of loosely consolidated material. They warned that a structural failure was not only possible, but likely under continued eruptive activity. More importantly, they described what would happen next. A flank collapse, they wrote, could displace a massive volume of seawater and generate a tsunami without any preceding earthquake. No seismic signature. No trigger for conventional warning systems. The scenario was clear, specific, and documented, but it stayed inside research. It did not translate into public emergency planning. Evacuation protocols were not updated. Early warning systems remained focused on tectonic signals, the kind of data they were built to recognize. On the surface, everything looked prepared. In reality, a critical gap remained. So, when the collapse finally happened, it didn't break the system. It exposed it. Because the technology worked exactly as designed, it just wasn't designed for this. To understand why Anak Krakatau is so dangerous, you have to go back to where it began, August 27, 1883. On that day, the original Krakatoa didn't just erupt, it destroyed itself. The explosion was so powerful that it was heard nearly 5,000 kilometers away, as far as Australia. It remains the loudest sound ever recorded in human history. The energy released was equivalent to around 200 megatons of TNT, more than 13,000 times the force of the Hiroshima bomb. But it wasn't the explosion that caused the greatest loss of life. It was the water. As the volcanic structure collapsed into the sea, it generated a series of massive tsunamis, some reaching heights of up to 30 meters. They swept across the coastlines of Java and Sumatra with overwhelming force. Entire coastal settlements were erased within minutes. More than 36,000 people died, most of them drowned, not burned. The impact didn't stop at the region. Ash and volcanic particles were blasted high into the atmosphere, spreading across the globe. In the months that followed, skies turned deep red and orange in distant parts of the world. Temperatures dropped by more than 1 degree Celsius the following year, altering weather patterns on a global scale. What Krakatoa left behind was not just destruction. It left a 6-kilometer wide submerged caldera, and inside it the slow emergence of a new volcano, Anak Krakatau, the child of one of the most violent events the planet has ever witnessed. Krakatau does not exist in isolation. It is part of a much larger tectonic system, one that has shaped some of the most destructive events in modern history. Beneath the Sunda Strait, the Indo-Australian plate is slowly diving beneath the Eurasian plate. This process, known as subduction, creates immense pressure deep within the Earth. Over time, that pressure is released in two ways, through earthquakes and volcanic activity. At Krakatau, both forces are constantly at work. This same boundary produced the Indian Ocean earthquake in 2004, a magnitude 9.1 event, one of the largest ever recorded. The tsunami that followed killed more than 230,000 people across 14 countries in a single morning. That was a tectonic disaster. Krakatau represents something different, but no less dangerous. Here, volcanic growth and structural instability exist directly above a deep undersea environment. Any sudden movement, whether from magma pressure or gravitational collapse, can displace water rapidly and generate waves that move outward with very little delay. What makes this region even more critical is population. To the east lies Java, home to more than 150 million people. To the west, Sumatra, with tens of millions more. Between them is a narrow strait, where coastlines are heavily populated, economically active, and constantly exposed. This is not a remote volcano. It is a high-risk system operating in one of the most densely inhabited zones on the planet. After the collapse in 2018, Anak Krakatau was dramatically reduced in size, a fractured remnant of what it once was. But that wasn't the end of the story. It was the beginning of a rebuild. Since then, the volcano has remained active, erupting intermittently through 2019, 2020, 2022, and now into 2026. Each eruption adds new layers of ash, lava fragments, and volcanic debris to the cone. Slowly, almost quietly, the island is growing again. And it's growing in the same way. The same processes that built the structure before the collapse are happening once more, material accumulating on steep slopes, forming unstable layers that are weakly bonded and highly vulnerable to gravity. Beneath the surface, pressure continues to build. Above it, the cone becomes heavier, taller, and increasingly fragile. Scientists monitoring the volcano are fully aware of this pattern. Seismic activity, ground deformation, and gas emissions are tracked continuously. The data shows a system that is active, evolving, and far from stable. But here's the critical point. The conditions that led to the 2018 collapse have not disappeared. They are returning. The volcano is rebuilding itself on the same foundation that already failed inside the same submerged caldera, above the same undersea drop-off in the same narrow strait. Nothing about the underlying risk has changed, which means the question is no longer about what happened in the past. It's about what is forming right now and how close it is to happening again. What makes Anak Krakatau so dangerous isn't just its history or even its current activity. It's the combination of both a system that has already failed in a way most warning networks were never designed to detect, now rebuilding under the same exact conditions. The science is not uncertain. A flank collapse can happen again. The structure is unstable, the processes are ongoing, and the geography has not changed. A steep volcanic cone rising above a deep underwater slope, positioned in a narrow strait where waves can travel fast and reach coastlines in a matter of minutes. In 2018, people had no warning. Not because the data didn't exist, but because the system wasn't built to recognize what was happening. That gap still matters. Monitoring has improved, awareness has increased, but the fundamental challenge remains translating complex geological signals into real-time decisions that reach people before it's too late. Because when collapse begins, there is no time to debate, no time to interpret, only time to react, and often that window is measured in minutes. So the real question is not whether another event will occur. It's whether the next signal will be understood fast enough to make a difference. What would you do with less than 30 minutes of warning? Subscribe to stay ahead of critical global risks and real-world events that rarely make headlines. This channel breaks down complex science into clear insights you can actually use. Like, comment your thoughts, and share to help others stay informed and prepared.